Hello, and welcome to 5 Minutes With, a podcast by Geoscientist magazine. My name is Marissa Lowe, and today I'm joined by Sian Evans, a postdoctoral researcher at the University of Oslo. Can you tell us what you're currently working on?
So my current research focus is actually on the geological storage of CO2. If you're not familiar, it's the concept that instead of emitting CO2 into the atmosphere, we can actually capture that CO2 instead and then inject it underground, where it can then be stored on geological timescales and not have, catastrophic effects for climate change. So as a structural geologist, my background is all in structural geology. I'm mainly interested in how the rocks have deformed over geological timescales, so how they've bended and broken. So ultimately, I am trying to assess which are the best sites for CO2 storage, so the ones that have the largest capacity for CO2, and also the ones that have the minimal risk of leakage. For example, faults can provide leakage pathways that the CO2 could travel along. I'm especially interested in salt because salt has a really unique way of deforming.
Amazing. So what kind of scale are the structures that you look at then?
We're looking offshore. I guess that's the first thing to say. So we're taking images of the subsurface, so seismic data, which is like an X-ray of the subsurface, so that we can look several kilometers down into the rock as well. It's a huge length scale, but the structures themselves that we're looking at are also on the kilometer scale generally. So one of these salt structures, they form these nice domal shapes, which can store CO2. They can be 5 to 10 kilometers across.
Could you tell us a little bit more about how we store CO2 in rocks? To me, CO2, it's a gas, it's in the air. How on earth do we store it underground?
We actually we capture the CO2 at the point where it's emitted. For example, in Oslo, we have this waste to energy facility that's looking to fit a CO2 capture facility. Then we can inject it as a supercritical phase. So that's something between a gas and a liquid, basically. And we inject it as a supercritical phase into the subsurface at high pressures. And then the rock that we inject into has to have some pore space available. So sandstone is a good one, for example. It's like a sponge, which means it has these little holes available between the grains. And then we can inject it into that space that's available, and it should be stored then safely on geological timescales.
Great. So what is a typical day for you at the moment?
So a typical day, I guess a typical day for me is one where I am in the office. But one of the things I also really enjoy about my job is I'm also not in the office. So I often go on field work, and this season has been particularly busy. For example, a couple of weeks ago, I was on field work in Namibia for a couple of weeks, which was super exciting. But a typical day would be one where I probably am in the office. And in that case, my time is divided between research and also teaching as well. So I teach master students in structural geology and also supervise some students. So I help them with their projects. And then I do my own personal research, of course. So that could just be me on a computer interpreting my seismic data or working with my collaborators. We have quite a nice team here now, all working on CO2 storage related problems, and also some external collaborators as well. So yeah, it can be a really varied day depending on if I'm teaching, researching, or have various other things going on, which I love.
So that leads us nicely on to what's your favorite thing about your research and your work?
As an academic, I kind of have to say the freedom of the job is really one of the reasons I stay in academia. So I am a problem solver at heart, as a lot of scientists would say they are as well. And I really love to get stuck into a particular geological problem, see something strange in the data and really follow it, dig into it and try to figure out what's going on. How did it get there? What kind of implications is it going to have for CO2 storage? And in academia, we really have the time and space to dig in quite deeply into a particular problem and have that aha moment where you have a theory of how this might all fit together.
What advice would you give to someone hoping to work in your field and get involved with structural geology and research?
rather than just network, I would say really find and value the people who help and support each other, because academia can be a very individualist place. And when you find that small network of people who are really out there to make time for each other and help each other, that's a total life raft in academia. So go for quality of connections over quantity of connections, I would say. And yeah, help and support other people as much as you can.
Well, thanks so much, Sian, and best of luck with the rest of your research.
Thank you.